Hello, everybody. We are going to start a new section today that we are going to talk about indirect measurement. And indirect measurement is a way of measuring things that we may or may not be able to measure directly. And so we are going to use proportions, similar figures, and things like that to help us measure things indirectly. All right, without actually being able to jump up there with the tape measure and whatnot and measure it. So we're going to have to think back to our similar triangles that we dealt with in the previous unit, and so here's how it's going to work. So let's start with one. The student wanted to find out the height of a giant inflatable ape, this guy over here. She measured the ape's shadow and her own shadow, as you can see in the diagram. The student's height is 5 feet 2 inches. What is the height of the ape? All right, so 5 feet 2 inches. Let's convert that. Let's convert inches into feet. So we're dealing with all these decimals here. So 2 inches, there are 12 inches in a foot. So we're going to divide by 12 inches, and that will equal feet. And so we get 1/6 of a foot, or approximately 1.67 for the feet. So 0.167 feet is what we're dealing with. So the height of this person is 5.167 feet. And over here we have the shadow was measured to be 10 feet 6 inches, and 6 inches converted into feet, dividing by 12 inches will give us in terms of feet. So that is a half a foot. So over here we have 10.5 feet is the length of the shadow. Now that we have everything into feet, we can go ahead. We could have converted it all into inches and it would work just the same. But basically we just needed that. And so we're looking for the height of this. And we'll notice that since the sun is somewhere up here, we'll draw a sun up here. Since the sun is somewhere up here, it's hitting this inflatable ape and is casting a shadow down here, and the sun is basically in the same position for the student that wanted to measure it. So we have an angle that is congruent right here, and we also have that the student is at a right angle to the ground, and so is the ape. So these two triangles are similar, so the sides should be in proportion to one another. So we can set up fractions and set them equal to each other to help us find the height of the ape. So what we'll do is I'm going to go, and you can set them up different ways. I'm going to use this smaller triangle first, so I'm going to say 3 is to 5.167 as, in this case, the shadow was 3 feet, so the shadow down here would be 10.5 is to the height, and so we did shadow over here to height, and so we have to do shadow to height over there, and the height is what we're trying to find, so that's my unknown piece of information, so I'm going to call it x. So again, one of our ways of undoing this is to cross multiply. So I will multiply the 3 by the x, so 3x will equal, and then we need to know what 10.5 feet times 5.167 feet is, and that's approximately 54.2535. And so then as I do this, then the only thing left for me to do to find the actual height of the gorilla is to divide by 3 to get x to stand alone. And when I divide by 3, I end up with 18.0845 feet. And if I wanted to convert that into inches, I would just take that decimal of the 0.08445 and multiply it by 12, because there's 12 inches, that's part of a foot, and that's approximately 18 feet and 1 inch, approximately. Okay, so either one of those answers would be okay for this, but this is how we're going to be doing indirect measurement. So let's try another one. All right, so we've got this giant pineapple here, and again, the student wanted to find the height of the giant pineapple statue. It's in, it looks like Nambour, Australia. She measured the shadow of the pineapple to be 8 feet 9 inches. Her shadow was 2 feet. She is 5 feet 4 inches, and so we're trying to find the height of the pineapple again. Again, let's notice that angle 1 and angle 2 are the same because, again, the sun is somewhere up here and is shining down at the same angle, so this angle 1 and angle 2 are congruent. The student and the pineapple are also at a right angle to the ground, so we end up with angle-angle similarity again for these two triangles. So now we just need to kind of work around what these are. Again, I'm going to convert the 4 inches into feet. So 4 inches divided by 12 inches will give me feet, and 4 divided by 12 is basically a third, which we'll write as 0.333. We'll just use 3 threes. It's repeating threes, but there is that's of a foot, a third of a foot. And over here we have 9 inches, and so we'll take the 9 inches and also divide it by 12 inches, and that'll get turn it into feet. Again, you could turn this all into inches, and it would work just the same. I just don't feel like multiplying. I'm going to deal with the decimals here. So 9 out of 12 is 0.75 feet. And so now we have that the student is 5.333 feet repeating, and the pineapple shadow is 8.75 feet. All right, so now we're going to set up a proportion to help us solve this problem, and I'm going to go shadow to height again for each one of these. So the shadow in the girl's case here is 2 feet to her height of 5.33 repeating. And that should be equal to, well, we don't know the height of the pineapple, but we do know the shadow length, and the shadow length is 8.75, but we don't know the height, so we're just going to call it x. Now, if I cross multiply these, I'm left with 2x equals, we're going to multiply this out, and we end up with, this is 46.666 repeating, for a long way here, so we'll call it that. And so then if we divide by 2, divide that answer by 2, we're going to end up with 23.333 repeating, and that is feet. And if I want to and I already figured out what 0.333 repeating is, it's 4 inches. So in feet and inches, this is 23 feet and 4 inches. Oops, I don't need the fraction there. And 4 inches would be the height of this pineapple, approximately. All right, and so that's how we do indirect measurement. We don't actually have to measure the actual shape. We can do it by using other pieces of information. All right, so let's do one more. And so we found the world's largest walleye. It's a statue in International Falls, Minnesota. And so we want to find the height of this statue over here. And basically this time we're putting a mirror on the ground, and we have a person standing over here measuring 6 feet tall. When they're looking down, their eyesight is 6 feet tall. So they're looking down on the ground here, and they notice they are 5 feet away from a mirror. I put a mirror on the ground, and what the mirror is doing is the person is standing here looking down into the mirror, and it's reflecting the very top of the statue up here. So this angle here is the same as that angle there. The person is hopefully at a 90-degree angle to the ground, and over here where they were measuring the height of the statue is also at a 90-degree angle to the ground. So basically we end up with similar triangles again, and so when we do these similar triangles, we can go ahead and set up a proportion. We can do height is to distance from the mirror, as distance to the mirror is to the height. And so again, this is very similar to what we were just doing in the previous example, but we don't have to convert. So this time we've got 6 over 5, so we've got height over distance, and so over here we've got to do height, which we don't know of the walleye, and the distance 23. So if we cross multiply these, we'll get 5x here. So 5x will equal 138 here. And so if we divide by 5, 138 divided by 5 gives us basically x is 27.6 feet, and if I wanted to convert the 0.6 into inches, I would say that that is approximately 7 inches. All right, so this is 27 feet and 6 inches high. And so that's really what we're looking for when we're doing indirect measurement. So it's just going to be a matter of setting up these proportions and solving them as we go. All right, and so we'll do a few more of these guys in class.